So today we're going to talk about learning target 2, which says I can construct a scale model or a scale to model a data set or a real world situation. So here are our 3 data sets, and we're going to construct a scale for each of these graphs, which means we're going to decide which numbers to put along the x-axis and which numbers to put along the y-axis to cover all of these points. To do that, for each axis, determine the smallest and largest values. I just want to remind you, make sure that you have your notes out right now. If you don't, pause this video and take them out. And make sure that you're following along with me, and anything I write on this paper, make sure that you write on your notes. If I'm going too fast, remember you can always pause the video to catch up. So after you've identified the smallest and largest value, so let's go ahead and do this in this first set of data. In this first set of data, for the x-axis, my smallest value is there, 2, and the biggest number is 27, so that's my largest. Over here on my y-axis, the smallest number is 10, and it looks like the largest is 73. Okay? So we have a smallest and a largest in each axis, in each variable. Now, find the lowest or the smallest, you could think of it with either of those words, the littlest number that you can count by consistently and still cover up to the highest value. So for example, what's the smallest number I can count by on my x-axis and still make sure that I make it up to 27? The key here is you want to make sure that you're counting by a consistent number. A lot of students will label this first little mark here as a 2, and then a 3, and then an 8, and then a 10. They'll just use these numbers to label down here, but that is not correct. You cannot do that. You have to find a consistent number to count by. So, if I count by 1s, I'll get from 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Not high enough. So I need to make it all up to 27. So let's think about 2s. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30. That gets me there. So 2 is the smallest number that I can count by consistently and still get all the way up to this highest value. So I'm going to label my x-axis counting by 2s. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30. Okay? Kind of hard to read that, but I was just counting by 2s. If you need to pause the video and do that, feel free to do that. Over here, I need to make it all the way up to 73. So to do that, I am going to, let me just try 5. So if I go 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70, 75. So 5s actually work. I can count by 5s and make it all the way up to 73. I just chose 5 and it happened to work because that seemed like it might be close. If it didn't work, if I didn't make it all the way up there, then I would want to try counting by 6 or 7 or maybe even skip up to 10 until I can find a value that will make it so when I count by that, I can get all the way up to 73 by the end of my graph up here. So we said 5s work, so we'll go 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70, 75. So what we've just done is we've labeled this graph with appropriate an appropriate scale on the x-axis and an appropriate scale on the y-axis. We constructed appropriate scales to model this data, and then we could go and plot our points. We're not going to plot our points. That was the last learning target, but that's what we would be able to do now that we've done that. Okay? We didn't have to worry about number 3 yet. We'll talk about number 3 down here in this bottom example. Let's look at this one. This is the same thing, only now we have some negative numbers, so we're going to use a graph that has quadrants 2, 3, and 4, because we use quadrants 2, 3, and 4 when we have negative numbers. So, again, my lowest number here is -7. My highest number is 9. So on my x-axis, if I count by 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, I can make it all the way up to 9 going this way. -1, -2, -3, -4, -5, -6, -7. So I can make it all the way down to -7 going that way. So 1 works. So that's what I'll label this as. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. -1, -2, -3, -4, -5, -6. Okay? And again, if you need more time to do that, feel free to pause this video and fill that in. Next, let's look at the y's. For the y-axis, the lowest number down here is going to be -8, and the highest number up here is going to be 20. So if I count by 1, that's not going to be enough space. I'm going to run out of room. There's just 10 lines here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I'm going to try counting by 2s. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. It works that way. And I need to get down to -8. So -2, -4, -6, -8. I'm still on the graph. So counting by 2s works. I need to count by the same number consistently all along the x-axis and all along the y-axis. They can be different from each other. I can count by a different number on the y-axis than the x-axis, as long as the x is the same all the way across and the y is the same all the way up and down. So I'm going to count by 2s. So we have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. -2, -4, -6, -8, -10, -12, -14, -16, -18, -20. So I've just taken this data and appropriately labeled my graph with an appropriate scale for this data. So my next step again would be to plot all these points on here, but I don't need to do that right now in this learning target. So let's look at this last one. Now here, my lowest value is 75, and my highest value is 105. So if we think about this, there is a big gap between 0 and 75, and then from there, all the numbers are just counting by 5. This is what this third step is talking about. It says determine if you need a break. Is there a relatively big gap between 0 and the lowest value? If the answer to that question is yes, then you need a break. Here, there's a pretty big gap between 0 and 75, and then it just starts counting by 5. So you have to jump a bunch to get there to 75, but then it counts pretty closely together. So what we're going to do is we're going to add in a break right here. It's kind of like a skip a few. It's like a little lightning bolt or a little heartbeat monitor thing over the axis between 0 and the first little line here. And what that says is skip a few. So it's like when you were little and you counted 1, 2, skip a few, 99, 100. This is 0, skip a few, and then we'll start counting. And that allows us to skip 1 through 74, and then just start our graph right there. So, and keep in mind that when you do that, the y-axis, or the y-intercept of your graph will be skewed, so you cannot look at your graph to follow it back to see what the y-intercept is, so just keep that in mind. So we're going to make a skip a few. I need to get from 75 to 105, that's a spread of 30. I have 15 lines here, so I'm going to count by 2s. So I'm going to start with 75, 77, 79, 81, 83, 85, 87, 89, 91, 93, 95, 97, 99, 101, 103, and I almost made it. Because I'm so close, I'm just gonna do this. Sometimes that's okay if you're just that close. 105. Now over here I have the same problem. I'm taking a big leap to get to 500, and then from 500 to 650. So I'm going to make a skip a few on my y-axis also. And then I'm going to start, and I'm going to count by tens, because if I have 500, 510, 520, 530, 540, 550, 560, 570, 580, 590, 600, 610, 620, 630, 640, and then I'm just missing one right there, so I'll just extend my graph up one more, and then I can make it. Otherwise, I would have to count by 11s to get there, and 11 is an awkward number, so it's easier just to make it work like this. So make it work like that, and then I'll count by 10. So 500, 510, 520, 530, 540, 550, 560, 570, 580, 590, 600, 610, 620, 630, 640, 650. So now I've also made appropriate scales to model this data. Remember, I looked for the smallest and largest values. I found the smallest number that I could count by consistently and still cover all the values up to the highest one on my axis. And then I determined if I needed a break if there was a big jump between 0 and my number. And that is how you construct appropriate scales to model data.